Right, okay. So during the last few clips, we have investigated actually how to factorize using common factor method. Whether if you find a common factor, you can take it out. Now here, second method is a very important method. Actually, this is quite important. Um, Method two, factorization using factorization of quadratic type of functions. For example, let's say we have a function like this to factorize. The question is this: 5x squared plus 25x plus 30. Okay, we try to factorize this fully. The question would be factorize fully. Factorize fully. Factorize fully. Or fully factorize, whatever way you like. Factorize fully. The first thing, then we would look at when you see something like this, whether there's a common factor. So let's see whether there's a common factor or not. We can clearly see 5 is a common factor because 5 goes into everywhere, isn't it? You can divide 5 by 5, you can divide 25 by 5, you can divide 30 by 5. So 5 is a common factor, obviously. So I'm going to take that 5 out. So what you're going to get here, x squared plus 5x plus 6. Now this is partially factorized. It's not completely factorized. The reason is this is a quadratic function. There's a possibility that we can factorize this as well. So that's the reason this topic is about quadratic functions. So we can factorize this further. To factorize this one, let's take this separately. Okay. So I'm going to rewrite this one here. Just separate it to see how to factorize it. I'm just going to write it, a bigger version of it. This is what we got. Now, the method is this. This is how it goes. You see the coefficient of x squared is 1, isn't it? Because nothing there which means 1. I'm just going to use this sort of like a standard method here because it's very useful. There's a shortcut as well, but obviously you guys probably know the shortcut already. But I'm using the slightly longer version of method because it's very useful in when you're doing a quite sort of like a, other type of factorizations. You will see in a minute. Because shortcuts actually, it doesn't really helpful when it's come to other stuff. Okay, so 1 times 6, 6. Okay, so we're going to write plus 6 because 1 times plus 6, we're going to times them together. 1 times plus 6 is plus 6. And I'm going to write the factors of plus 6, starting from 1, basically. 1 times 6, 2 times 3, that's it, isn't it? 1 times 6 and 2 times 3. Again, 6 times 1, the same thing as 1 times 6. So if I want, I can write 6 times 1. And 3 times 2, no point of writing all these things, so because they're again recurring. The step 2 is try to work out two numbers here using that pair or that pair. When you add them together, it should make 5. When you add them together, that should give us 5. Okay, so the whole idea is when you times them together, we should give us 6 already. But add them together, give us 5. Now, I would say when you're writing these things, it's better to write like this, plus 1 times plus 6. Plus 2 times plus 3. If you write like this, actually, when you can write some other things, like minus 1 times minus 6. Because minus 1 times minus 6 should be plus 6 as well. Minus 2 times minus 3 would be also plus 6. Now, there are 4 pairs, isn't it? 4 pairs of possibilities to give us plus 6. However, let's see how many pairs can actually yield when you add them together to give us this 5. If you add them together, that 2 give us 7, so it's no point. Add them together, give us 5, see? So that's possible. Add them together, give us minus 7, is no point. Add them together, give us minus 5. What we require is plus 5, so we just eliminate that. You can always find only one pair. If it's factorizable, you don't find more than one. So that's the viable one. So what we're going to do, we're going to rewrite this one like this. We're going to expand this. This 5x can be written like 2x plus 3x. So nice trick, plus 6. If you look clearly, if you look at this carefully, you will see that actually 5x, these two expressions are exactly the same. These two expressions haven't really changed. You haven't really violated the function. X squared there, see, add them together, again you're going to get 5x. The 6x is there. So that's no really violation of the original function. So the only thing is this is written in a more conducive format for factorization. Right. Okay. The next step is this. Now we have 4 terms now. Before we had 3, now we have 4 terms. Look at this 2 and look at this 2. Separate them. We can look into the common factor here. See, again we look at common factor. See, it's quite important. What's the common factor here? X. Isn't it? X is the common factor. Take it out. If you take x out, you're going to get x there. And you have taken x out, what you're going to left with is 2 there. Okay? So that bit is done. And if you look at this pair, what's the common factor? Plus 3, isn't it? Plus 3 is common. Take it out. You're going to get x there, and you're going to get 2 there. Now you can see x plus 2 is common in both of them. I think in the previous clip actually I showed a similar situation. We had 4 of them like that, and it occurred like this, x plus 2 and x plus 2. Now we can take x plus 2 out. What are you going to get? I'm going to take x plus 2 out from here, and we're left with, it's gone, and we're left with x plus, and that's gone as 3. There you go. That's the answer. That's the factorization for that. Now what we did here, we first used the common factor. You took the common factor out, and we realized there's a quadratic function here, quadratic expression. We have factorized this one. Now we can plug these 2 factors into that. So that gives the fully factorized version of answer. So let me plug it back then. So the answer would be 5 times x plus 2 times x plus 3. X plus 2 times x plus 3. That's the answer. That's the full answer. That's partial answer. There's a full answer. Fully factorized now. This is. Okay. So the whole idea here is to factorize quadratic expressions. Okay. Right, let's try another question this type. Right. Okay, so let's see. Let's say we have a question like this: x squared plus 10x plus 24. Alright, so again, we know we can see the coefficient, the front is 1. So 1 times 24, we're going to get plus 24. 1 times plus 24, because plus 1 times plus 24 is plus 24. Go write all the possible factors here. 1 times 24, 2 times 12, 3 times 8, 4 times 6. That's basically, again, 5 times nothing, 6 times 4, you got it. And again, you're going to have 8 times 3, the same thing. And again, obviously, if you want, you can go for 12 times 2, again, that's the same thing. So, and also, we can see plus 24 can be made, all these plus values, and also can be made using minus values, isn't it? Minus 1 times minus 24, minus 2 times minus 12, minus 3 times minus 8, minus 4 times minus 6. Now the requirement is, we try to find 2 numbers, times them together to give us plus 24, same time add them together should give us plus 10. Now let's see what 2 numbers added them together give us plus 10. That's not going to give us plus 10 because it's going to give us 25. That's going to give us 14, it's no point. That's going to give us 11, it's no point. Well, that's the one. 4 and 6, plus 4 and plus 6, add them together, you're going to get plus 10 basically. This one's always gives a minus answer, so there's no point. So we can then write this one like x squared plus 4x plus 6x plus 24. It doesn't matter which you're around, you can just flip this one, doesn't really matter. Just you get the same answer by doing whatever. So common factor again x, take it out, you're going to have x plus 4. Common factor here is 6, take it out, you're going to have x plus 4. You should get exactly the same things, otherwise you know you did something wrong. Okay? So x plus 4 can be taken out as a common factor from both. What you're going to get, once you take an x plus 4, you're going to get x here. And you're going to get 6 here, basically. That's it. That's the fully factorized form. Because there weren't any common factors to take out initially, so that's it. Okay? So like we mentioned in the very first click, when the very first one, now these are two factors. If I divide this one by x plus 4 for an example, I'm going to get x plus 6. If I divide that original expression by one of the factors, I'm going to get the other factor. This is actually called the factor theorem in C2. In a sense, that's what. Or if I divide that by the other factor, I'm going to get the other factor. See? So that's basically it. Okay. Let's move forward. Let me show you some other examples in slightly different versions of the question. It's very important, these things are, like we mentioned before, they're useful. Factorization is very, very important. Useful for solving equations, sketching curves, so many things like that. Simplifying equations, even evaluations in certain cases. Yeah, so it's very important. Right, so let me do another one, slightly different one. Let's say we have a question like this. 2x squared plus 7x plus 5. Now in this question, it's slightly different because the coefficient is 2 now. Before we had 1. But however, the exact same method can be followed. 2 times 5, which is plus 10. Okay? And we can write basically plus 10. We can factorize it. 1 times 10, 2 times 5. That's basically it. These are all our plus values. And also we can write minus terms, minus 1 times minus 10, minus 2 times minus 5. Now the step 2 would be to find out whether two numbers, a pair of numbers basically in these ones, to find whether when you add them together they should yield 7. If you add these two, you're going to get 11, so it's no point. Add them two, you're going to get 7x, so that's good. Others going to give us negative answers. So we can just add them together then. So 2x squared plus 2x plus 5x plus 5. Here we have 4 terms now. What's the common factor here? Is 2x, isn't it? Take 2x out. 2x is common factor, right? So I think it's clear. So you're going to get x plus 1. Basically I've used this 2, the common factor. And again use this couple. What's the common factor is 5. I'm going to get x plus 1. X plus 1 is a common factor. Take x plus 1 out. So what you're going to get is 2x plus 5. That's it. So let's say in a particular question, if you ended up getting 2 different values here, for an example, then you know you've done something wrong. Either thing is not factorizable. Basically, you have done something wrong. You should get exact same things. That's the only way you can factorize. You should get same expressions. However, don't force it to make it same. If it's going to become same, if you do properly, it will become same. So don't try to make it look like same somehow. Okay, so learn it properly. Okay. Cool. So let's look into another few. They're quite important, these things are. And later on we'll see the applications of this factorization as well. Okay. We do another one or two questions. Let's say we got something like this: minus 3x squared plus 5x plus 2. So minus 3x squared plus 5x plus 2. That's the expression we're trying to factorize. Minus 3 times 2, we're going to get minus 6. See? Right with the sign or the symbol, sign. Minus 3 times plus 2, minus 6. Write all the possible factors, multiples basically. You can write minus 1 times 6, minus 6. Minus 2 times plus 3. Yes. Minus 3 times plus 2. And also actually the previous one we forgot to write 6 times, minus 6 times plus 1. Okay, so these are the minus, when you times them together, you're going to get minus 6. That's all, I think, isn't it? That's all. However, we're trying to work out a pair of them. We should have them together, give us 5x. Minus 1 plus 6. This yields 5x, isn't it? What about others? This one yields minus 5, this one yields minus 1, this one yields 1. So the first pair is the right one. So we're going to rewrite it. We're going to write those factors. 5x, we're going to write 5x in terms of that. Like exactly same thing what we did before. So minus 3x squared minus 1x plus 6x plus 2. When you're writing x, write minus. When you're writing this x, write 1x. It's useful to understand things sometimes. Look at the common factor here. Minus x is a common factor, isn't it? Minus x, minus x. So minus x is a common factor. Take it out. So what are you going to get here? Basically 3x plus 1. Alright? So basically common factor here you're looking at minus x. What's the common factor here? 2. 3x plus 1. Alright? So 3x plus 1 is common factor. 3x plus 1 can be taken out. And what you're going to get is here minus x plus 2. There you go. That's basically it. Okay. Learn this method. Learn the standard method. It's very important. The shortcuts work sometimes. Otherwise you have to just rely on guesswork. The guesswork, it'll be a hit or a miss. You might get it, you might not. Why don't you learn it properly? Just do it solid method. You can get almost all the time right if you know solid method. Useful rather than just using shortcuts. Shortcuts are good probably when you have just one there, obviously. They have a place, obviously. But when you have these numbers like that, most times shortcuts fails actually, unfortunately. All right. Cool. Okay. So let's see another one. And probably can look into the application side. And there's another method actually left as well to explain factorization. Okay. Say we have something like minus 4x squared plus say 6x plus 10. Say we got 8 and 4x. Okay, this is the question. We try to factorize it. Like we said, when you're factorizing, you always look for a common factor first, if there is. In the previous ones, there weren't common factors. You clearly see that. Here there is a common factor, which is 4. If you want, you can take -4 out, or you can take 4 out. Let me take 4 out as common factor. So what I'm going to get is minus x squared plus x plus 2. Okay. So that's partially done. Now we can check whether we can factorize this or not. We got minus means we have minus 1x, like we said. Minus 1 times 2, minus 2. And you can write all these possible ways of making minus 2. You can write minus 1 times plus 2. Minus 2 times plus 1. That's all. And we can make x means 1x basically. 1x using this pair. No. Isn't it? Because plus 2 minus 1, add them together gives us 1. So I can just put a big bracket here. Because 4 outside, I'm going to write minus x squared plus 1 can be written minus x plus 2x plus 2. Maybe a bit too big brackets. Now minus x squared. What we got here, common factor is minus x, isn't it? Take minus x out. We're going to get x plus 1. Plus 2, x plus 1, because minus x is taken out. Minus is common. Minus x is taken out. X is common as well. So we're going to get x plus 1. And also here, common 2 is common. Take it out, you're going to have x plus 1. Now x plus 1 is common. Take that out. Going to have x plus 1. And minus x is common. Minus x plus 2. That's it. You can always justify these answers by just multiplying back and see whether you're going to get the original expression or not. You know, especially at the initial stages, you better do that. Because it's good for just, you know, mathematically, you know, practice, isn't it? Even open the brackets and all that. Alright, so I think that's basically it. Let me write a few questions. You can try it yourself after watching this. Alright, try this at home. And there are plenty of questions you can find in the book, C1 book, basically. Try this few. Alright, so also try these few questions, factorize them, factorize fully, okay, factorize fully. Alright, cool, I think it's enough for the time being, and probably I'll do some more clips which is related to the next method of factorizing, and also the applications, and you can probably go a bit deeper and all that. Cool. Okay.